All right. Hello, all. Looks like most have joined and we can begin. My name is Edgar and I am with AEE Solar. Today we are joined by Enphase. In today's webinar, we will learn how to sell the Enphase Energy System with IQ8 microinverters and a lot more. As a reminder, we will have a Q&A session following the presentation. You are more than welcome to submit your questions via the question section located on your control panel at any time during the webinar. We will do our best to answer as many questions as possible after the presentation has concluded. Alrighty, let's dive in. I'd like to introduce you all to Tony, a senior trainer at Enphase Energy. Without further ado, Tony, I'll pass it on over to you.
Thank you, Edgar, and thanks for the introduction. And thanks to all of you for joining us today for this training. It's a great opportunity for us to be able to meet in this virtual way and teach you about our products and our systems. And we just appreciate you taking the time out of your day to learn more about what we have to offer. All right, so just give me a second to share my screen here. Okay, can you all see my screen? Or Edgar, I guess you could answer, see my screen that says selling the Enphase Energy System?
Not yet, there you go. It is live now.
Had to click the second button there, all right. All right, just a little bit of background about myself. I've been in the solar business for about 14 years and got my start selling solar water heating systems for a San Diego company in 2008. And since then I've worked in a few different sales positions, selling PV batteries, solar thermal system. I've done tech support, kind of a little bit of everything, and really enjoy my job as a trainer at Enphase. I just love working with salespeople, love working with other solar professionals to convey all the benefits of our technology and help people be more successful in their jobs. I've worked for Enphase for about 3 years now, and I live in Monterey County, the Central Coast part of California. So since this is a training session, I'd like to lay out a few learning objectives. So this is kind of what I'd like you to take away from today's session. So after this session, you should be able to do these 5 things at least. Describe the key features and benefits of the Enphase Energy System. Explain the benefits of having control of the entire system from one application. Describe the unique benefits of the IQ8 microinverter. List the Enphase components that are essential for the 4 different basic configurations we offer. And also explain how the IQ load controller can help improve the homeowner's experience with their system. Let's start with the value proposition of the Enphase Energy System. So with the Enphase Energy System, the homeowner can have an all-in-one system, all components designed and manufactured to work together like one little happy family. And the entire system can be managed by a single application, whereas many other systems on the market have components from different manufacturers that are bolted onto each other that don't fundamentally speak the same language and basically aren't designed to work together. With the Enphase system, everything is designed from the ground up to function together. Not only does that give you the benefit of a better performing system, but you also have one manufacturer to deal with if there are any flaws or defects or have to return products, or troubleshoot. If you call our customer service, it's much easier for them to figure out where the issue is originating because they have visibility over all the components in the system. Our backup power systems can have just IQ microinverters with IQ8 series, that is, which can provide backup power during the daytime as long as the sun is shining and there's more power than the power demand of the home. Or our system can also incorporate batteries, of course. So for customers that require 24/7 reliable backup power, the best solution is a Enphase microinverter system coupled with our Enphase IQ battery system. So I want to talk a little bit more about the IQ8 microinverter because it has some unique capabilities compared to previous generations. Specifically, it is a grid-forming microinverter as opposed to a strictly grid interactive inverter, which is what the vast majority of solar inverters on the market are. So the IQ8 has this grid-forming capability, which means that it can even provide backup power during the daytime when the sun is shining without the support of a battery at all. So no battery in the system can still provide power during the daytime. And that's made possible because of what is called an ASIC, which is just a purpose-built microchip inside each microinverter that's extremely fast compared to previous generations. And that very fast speed allows it to instantly adjust its power output depending on the power demand of the home. And that high speed also allows the system to be very stable, so you don't have flickering lights or unexpected shutdowns when there are dramatic changes in power demand within the home. It also allows what we call sunlight jumpstart. So sunlight backup is the backup power feature during daylight, and sunlight jumpstart is a feature that allows the system to start up even if there's a battery connected to the system that has an extremely low state of charge. And other systems on the market do not have this capability, and I'll go into a little bit more detail on the next couple slides. It also allows more flexibility when designing systems. With a previous generation of our system, as well as other competitor systems on the market, the size of the battery is sometimes determined by the size of the solar system. In other words, if you have a large solar system, you may also need to get a large battery in order for it to be able to absorb power from the solar system without getting overloaded and shutting down unexpectedly. With the Enphase IQ8s, because of that fast reaction speed, you can actually pair a very large solar system even with a small battery. So in those situations where the customer just wants a kind of a small battery just for their essential loads, they have that option with Enphase regardless of the size of their PV system. So let's talk a little bit more about Sunlight Jumpstart, which is one of the more compelling features of the IQ8. So it's really an important feature for customers that want to be prepared for prolonged power outages, especially in areas where power outages are caused by things that affect solar production, like storm clouds or wildfire smoke in California, for example. So what you're looking at here is kind of simple animation of how typical AC coupled systems work. So I'm talking about non-Enphase systems and what happens with them if there's a prolonged power outage and the solar system's not producing. So essentially a system like this gets down to a low state of charge. Say overnight the battery energy is consumed by powering the essential loads and it gets down to 10%. The system will go into standby mode, and that means power is off for the homeowner. The battery does this because it doesn't know when the sun is going to be out again, so it needs to reserve some energy in the battery in order to be able to form a microgrid and allow the solar inverters to start up and produce power. I just want to clarify, in a typical AC coupled system, it's the battery inverter that forms the microgrid, not the solar inverters. In other words, the solar inverters rely on the battery to function. If the battery is dead, the solar panels can't work. So what happens is, the next day, the system is going to attempt to restart. The microgrid will be formed by the battery, and that'll signal the solar inverter to attempt to start up and start producing power. Problem is, with this scenario, if you've got a cloudy day, the system is not going to be producing power, or perhaps enough power to handle the loads of the home. During that startup process, the battery drains down a little bit. It uses energy in order to it uses energy when trying to start the solar panels. So what eventually will happen is the battery will get down to 2%, which is considered extremely low state of charge, and that battery is off until there's a utility grid or microgrid formed. The problem is, if this is happening the first day or second day of a prolonged power outage, this customer's solar and battery system is out of commission until the utility grid is back up, even if that's a week or 2 or 3 weeks later. Obviously, a very bad situation for a homeowner that invested a lot of money into a system and is expecting reliable backup power. Now, the difference between the Enphase system and other AC coupled systems is that because the IQ8s on the solar array are also grid forming capable, they can overcome this problem with a very low state of, or extremely low state of charge battery. So with an Enphase system, initially the same problem occurs. The battery gets down to an extremely low state of charge and the system will shut off. The key difference, however, is the next day when the sun comes out, the solar panels and IQ8 microinverters can form the grid by themselves without the help of the battery. So even if the battery is extremely low state of charge and can't support the solar inverters can form the microgrid by themselves. That means the system is going to automatically recover from an extremely low state of charge, and that battery will get charged up by that solar array, assuming there's enough sunshine in a given day to power the loads and recharge the battery. So this is a key difference. We've seen many cases over the past couple of years with all the power outages we've had, especially in places like Texas and California, where a lot of customers have experienced week or 2 or 3 weeks of prolonged, very prolonged power outage. The Enphase system being able to automatically recover with IQ8s is a huge benefit compared to systems that will shut down and stay off. So with that, I'd like to move on to the 4 basic configurations that we offer. So the first one here is solar only. So this is a conventional grid-tied system that does not provide backup power, but provides electricity to the home, offsetting their electricity bills. The next column here is sunlight backup, which I already described. So sunlight backup can provide backup power to the home's essential loads, as long as there's enough sunshine, irradiance, etc., to provide more power than the home's power demand. The next couple columns are systems with batteries. Home essentials backup is basically partial home backup, where you are supporting just the essential loads of the home with a relatively small battery. And the last option, full energy independence. This is our most robust system that will be custom designed and custom sized to meet 100% of the power demand of the home. So the idea here is whatever kind of solution the homeowner wants, we can provide, whether it's solar only, sunlight backup for limited backup during the day, or a full-on robust battery backup system. So just another quick overview of sunlight solar only with some simple single lines here. So as you can see, it's just solar panels with Enphase microinverters connected into the home's electrical system, backfeeding power, reducing consumption from the utility, and powering that home with clean green energy. Next is sunlight backup. So as far as equipment goes, with sunlight backup, we have to have a system controller too, specifically in the system. Now the IQ system controller is the smart switch, or if you want to get technical, from the NEC term is microgrid interconnect device. One of the main functions of this device is to disconnect from the utility grid as soon as there's a grid outage, and it signals the other components in the system to instantly provide backup power to the home. So even though there are no batteries in the system, with the system controller 2, if it's sunny out, there will be a seamless transition from being on grid to disconnected from the grid. Just want to reiterate that the sunlight backup configuration requires the controller 2. Otherwise, it would just be solar only. Because the amount of power is quite variable and is going to be limited compared to a system with batteries, we require an essential loads panel, so you're not trying to power the entire home with sunlight backup, as well as at least one IQ load controller. The IQ load controller can instantly disconnect power to larger loads, and it also allows the loads to turn on based on a schedule, so that you don't have a lot of loads trying to draw power all at the same time first thing in the morning. So it sort of delays those loads turning on when the system is off grid. Here's a single line with just a little bit more detail, so you can see we've got the IQ8 microinverters feeding into the IQ Combiner. That's our combiner box that also has the IQ gateway, sort of the brains of the system, connected into the IQ system controller 2, which feeds the essential loads and is controlled by that load controller. When the utility goes out, the system controller instantly disconnects from the grid, and the IQ8 microinverters with solar will instantly power the essential loads of the home. So how is a system like this going to work in the real world? So the key thing to understand is that it's going to be a stable backup power system as long as the power demand of the home is less than the potential power of the system. The system is able to ramp the power output up and down based on exactly what the power demand is. So here on a bright sunny day in the summertime, with a typical system that's around 10 kilowatts DC or 8 kilowatts AC, this is potentially how much power the system will output, again, on a sunny day, probably in June or so when you've got high irradiance. As long as the power demand remains under the available system power, it's going to be on and stable. Eventually, at the end of the day, or any time during the day, that is going to shift and the power demand will exceed what the system can output. At that moment, power is going to shut off for that homeowner. So I have a couple columns here, basically ideal candidate and non-ideal or poor candidate for sunlight backup, because we want to make sure that not just expectations are set correctly, but that other important factors are taken into consideration when a salesperson is talking to a homeowner, and you want to make sure you're providing a solution that's going to work for their needs. So an ideal candidate for sunlight backup is someone that lives in a sunny climate, doesn't require backup power 24 hours a day, 7 days a week, isn't backing up loads with high starting surge, like air conditioners and pumps. Those loads that have that big spike in power demand when they first start, those can easily collapse a sunlight backup microgrid because power is limited by the sunshine, basically. And lastly, they want a low-cost backup solution with the option to expand later. Perhaps they'll add batteries at a later date. A poor candidate for sunlight backup is a customer that lives in a climate with frequent overcast or cloudy or foggy weather, like the Pacific Northwest, for example. Candidates that need backup power 24 hours a day are not good candidates. And candidates that have those loads with high starting surge, as I mentioned. And customers that really just want a complete, robust backup power solution right out of the box that won't need upgrading later. So now let's move on to battery systems. So with the Home Essentials backup option, a customer can add a battery as small as 3.3 kilowatt hours with the Enphase system, even if they have a pretty large PV system. The limit as far as the PV system with a backup power system from Enphase is what the what the IQ Combiner can support, which is about a 20 kilowatt DC system. Home Essentials backup system is designed to provide backup power just for the essential loads of the home. The IQ load controller pictured here is suggested but not required with Home Essentials backup. It is required with sunlight backup, but not required with Home Essentials backup. Although if the homeowner does have some larger electrical loads that small battery may not be able to support, an IQ load controller is a great idea to be able to disconnect or shed those loads when the system goes into backup operation. That leads me to another benefit. I mentioned this earlier, but I'll bring it up again. So with our system, you can have a pretty large PV system around 15.3 kilowatts AC, which is about 20 kilowatts DC. That's the max that you can fit into one of our IQ combiners. And that can be paired even with a small 3.3 kilowatt hour IQ battery 3. So again, a lot of flexibility when designing a system. The customer with a large PV system just wants a small battery just to power their fridge overnight. They can get that with Enphase. They're not forced into buying a 20 or 30 kilowatt hour battery. That leads me to another benefit of AC coupled systems, which is that the power of the battery and solar is additive. So during the daytime, as you can see, the solar power is going to add to the battery power. So the system would have nearly 10,000 watts or 10 kilowatts of available power on a bright sunny day. And that allows that customer to potentially run some larger loads during the daytime, loads that their battery by itself might not be able to support at nighttime. So with this system, the customer goes from having sunlight backup only during the day to having battery power or backup power from a battery 24 hours a day, 7 days a week. And the last option we offer is full energy independence. Again, this is basically whole home backup where you can have up to 4 of our larger IQ batteries for a total of 40 kilowatt hours of storage and about 15 kilowatts of continuous power to be able to run pretty large loads like air conditioners, pumps, even electric kitchen appliances, etc. Similarly to Home Essentials backup, there is an IQ load controller pictured here, but it's not required with full energy independence. It just may be useful depending on what kinds of large electrical loads that customer has. And the entire system is controlled by the Enphase app, whereas other systems, you might have a separate solar app from your battery app. Customers really like being able to just use one app to control their system. With the Enphase app, the first page you see here is status page, where you can see essentially how many kilowatt hours the home is consumed and the system is produced, batteries charge and discharge, with a nice infographic to make it real clear what's happening. And on the upper right-hand corner, it says live status. So that actually will open up a live version showing exactly how much power in kilowatts is flowing. So it's really nice to see in the moment exactly what the system is doing. The homeowner can even disconnect from the utility, from the app. Sometimes homeowners want it to sort of test the functionality before there's a storm coming or an unexpected power outage. You can actually disconnect from the app, test your system, and go back on grid without even going out to your electrical panel. You can view a lot of detail about what's going on with your system, like energy production of your solar and energy consumption of the house, as long as consumption metering is installed. And as you probably know, with Enphase, you get individual solar panel monitoring. So each individual panel is not just giving you information about energy and power, but for troubleshooting, we're able to see things like grid voltage, DC voltage from the solar panels, which can tell us if there's a problem with either the panel or the microinverter, even temperature. So it makes it very easy for us to troubleshoot issues with solar systems. Now, when our system is on grid, the homeowner has 3 options, 3 different smart profiles or basically operating modes to choose from. The first is full backup. So with full backup, the battery is only used, the energy in the battery is only used during backup power situations where there's a grid outage and the homeowner's relying on backup power. So for customers that are experiencing frequent power outages, or perhaps it's a seasonal issue for them, so during the fall and winter when there are hurricanes coming, they'll leave it in full backup. And the next mode here is savings mode. So with savings mode, that battery energy is going to be used to save that homeowner money if they have what are called time of use rates, where the price of electricity varies depending on the time of day. With savings mode, the battery basically will charge up during the daytime when rates are relatively cheap. And then when the time period goes to the peak period and prices go way up from the utility, the homeowner can use that energy stored in their battery instead of paying through the nose to the utility. And lastly, self-consumption. So self-consumption just means that the consumption of the solar energy and battery energy is always going to be prioritized over utility power, regardless of what time of day it is. Self-consumption is used by customers that basically don't get credit from the utility at a decent rate when they feed energy back to the grid. So why feed it back to the utility when you can use it yourself by storing it in your battery? And we're going to talk a little bit about NEM 3.0 later as well. So with NEM 3.0, for those of you that work in California, the whole credit structure that we're accustomed to with NEM 2.0 and 1 is being upended. So the amount of credit that customers get is going to vary dramatically and is not tied to the time of use time periods. So for those customers, a form of self-consumption, and Enphase is working on a customized mode actually for NEM 3.0 that's really optimized to save as much money as possible for customers with NEM 3. And we'll talk about that a little bit later. So let's pause here for a quick learning check or pop quiz. Obviously you're on mute, so you can't answer, but just follow along. True or false, Enphase recommends a maximum power ratio of 1.5 to 1 solar AC power to battery AC power when using the IQ8? So the answer here is false. So when I was talking about how with other systems and with before the IQ8, if you had a big solar panel, or sorry, big solar system, you had to have a big battery too. That doesn't apply with the IQ8 system. So you could go beyond this max ratio of 1.5 to 1 if you're using the IQ8s with our batteries. With a sunlight backup system, what occurs when the power demand exceeds the available solar system power? The microgrid will shut down because it will become unstable and power will go out temporarily for that homeowner. True or false? When disconnected from the utility, the amount of available power of a sunlight backup system is consistent during daylight hours. So the answer here is false. The amount of available power is going to vary a lot. It varies with irradiance. Okay, now let's talk about the fundamentals of sizing storage, and we'll talk about these concepts of energy and power to start off with here. So why is sizing a solar plus storage system properly so important? Essentially, it means that the system is going to have enough energy, power, and peak power to supply the customer with reliable energy. So first is energy. Energy is like the storage capacity of the battery, how much energy it can store. And that determines basically how long the battery will last under a given set of conditions. You can think of energy as like the capacity of a gas tank. Power determines what it's capable of running continuously. The more things that are on in the home, the more power demand there is. So the battery needs to be able to output enough power to run all the loads continuously. And thirdly, a properly sized battery will have enough peak power to be able to start up loads that have a high demand of power for 1 or 2 seconds when they first start, things like air conditioners and pumps. So yeah, as I mentioned, energy capacity is analogous to fuel tank capacity. A 10-gallon fuel tank is going to be able to hold more energy in it than a 5-gallon fuel tank. Same applies to our batteries. In the IQ Battery 10, that 10 refers to the kilowatt hour capacity. A lot of folks will accidentally refer to this as a 10 kilowatt battery, which is not accurate. It's a 10 kilowatt hour, which is the unit that we use for energy. Now we know what energy is. What is power then? Well, power is the rate or the speed at which energy is moving, either being consumed by an appliance or being delivered by a battery or solar panel inverter system. Some appliances like air conditioners demand a lot of power, typically 3,500 watts or even much higher for a whole home air conditioner. Whereas an appliance like a television will use a relatively small amount of power. It's consuming energy at a relatively slow rate. Now the relationship between power and energy is pretty simple. Kilowatt hours is simply the power output multiplied by hours. So in this simple example, if you have an appliance that demands 1,000 watts and it runs for 10 hours, it would consume 10,000 watt hours or 10 kilowatt hours over that 10-hour period. A battery, if there was a battery powering this appliance, it would have to have a power output of at least 1 kilowatt in order for that microgrid to be stable. Now, when we talk about power surge or inrush current, it's almost always related to motor-driven appliances. Motors require about 5 to 10 times the power to start up that they use to run continuously. So if that battery is not able to provide that startup power, the system might crash and power would go out for that homeowner. This is a typical motor that might be connected to a jacuzzi pump or small pool. It demands 960 watts when it first starts, but for about 1 second, it demands about 6 times that. So here we have some additional details about our batteries. The IQ Battery 3 has a 3.36 kilowatt hour capacity. its continuous power output is 1.28 kilowatts, and it can output 50% more than that, which we call peak power, for 10 seconds. That's 1.92 kilowatts. The IQ Battery 10 on the right is exactly 3 times the IQ Battery 3. If you took the cover off the IQ Battery 10, you would actually see 3 of the IQ Battery 3s connected to each other with that large cover over the top. So the specs are exactly 3 times. So 10 kilowatt hours of energy capacity, 3.84 kilowatts of power, and 5.76 kilowatts of peak power for up to 10 seconds. It's critically important to set realistic expectations with your customers regarding the battery system's capabilities. Because of the nature of an AC coupled system, everything increases in a linear manner when you add batteries to the system. So if you have two IQ Battery 10s instead of 1, that'll have twice the energy and twice the power and twice the peak power compared to 1. An IQ Battery 3, while it can power most modern fridges overnight without an issue, it is really not a robust backup power system. There are many plug loads, things that you could plug into a regular outlet, that a single IQ Battery 3 would not be able to support. So when offering a small battery, it's important to be very clear with the homeowner that they won't be able to run any high power, even plug-in devices like hair dryers, probably microwaves, things like that. With other loads running, it was probably going to be too much for the IQ Battery 3 to handle. So for a starting point for partial home or for the home essentials backup solution, we do recommend at least 1 IQ Battery 10. An IQ Battery 10 can easily manage anything that can plug into a standard 120 volt receptacle, including kitchen appliances, small kitchen appliances, that is, like microwaves and coffee makers, as well as a garage door. That's a critical load for many people in order to be able to get out of their garage. And many people will start with an IQ Battery 10 and see how that goes for them, and knowing that there's an option to add more batteries and more capacity and more power in the future very easily if necessary. For whole home backup, or if any large electrical loads that are 240 volt loads require backup power, we recommend at least 2 IQ Battery 10s. We call that an IQ Battery 20. With 2 IQ Battery 2 IQ Battery 10s, that system will have enough power to be able to run most large appliances, as well as the basic essential loads that are mentioned here. Now, if the customer is in an all-electric home, they don't have any gas or propane appliances, and they need to run multiple large 240 volt appliances simultaneously, then an IQ Battery 30 or 40 would be recommended, not just for the energy capacity, of course, but also to have enough power and peak power to be able to start multiple large electrical loads. So the point here is that the Enphase system is very modular. The availability of system size ranges from 3 to 40 kilowatt hours. So just about any scenario that you'll run across can be handled by the Enphase system. Now, how do you design the optimal system? We recommend using our free tool on our websites called the System Planner. The URL or web address is estimator.enphase.com. And we also encourage you to take a look at our partner, our company, SolarGraph. We acquired SolarGraph a couple of years ago. It's a very sophisticated solar design tool. Because it's an Enphase company, it also incorporates or allows you to very accurately size a battery system for that homeowner using the same technology that we use in the System Planner app. The System Planner looks like this. You enter just some basic information about the home and energy consumption, and it gives an initial simple recommendation for solar and battery. But you as a professional can click on additional configuration, and it takes you into this more sophisticated section where you can actually change the quantities of the different electrical loads that are being backed up. It breaks it out into essential loads and larger loads. And it's a dynamic tool, so it will instantly recommend the battery size based on the changes you're making to those inputs. And it also highlights what's driving the size of the battery, because the minimum battery could be based on the amount of energy required to power those loads overnight. It could also be how much power or peak power is required to handle those loads. So it's nice to very easily see what's the reason why this battery size is being recommended. Again, it's a totally free tool. There's a URL here at the bottom to go to the tool, and below that is a tutorial video, which will give you some tips on how to use this tool, especially if you're sizing storage for homeowners that have some challenging loads like air conditioners or pumps. Another quick little pop quiz here. So what's the unit we use for electrical energy? That would be the watt hour or kilowatt hour. The energy capacity of a battery system determines which of the following: what it can run, what it can start, or how long it will last. And the answer is how long it will last. So the energy capacity determines basically how long it'll last. Name an appliance with a high starting surge. Air conditioners and pumps are the biggest culprits. And what is the minimum recommended IQ Battery 10 quantity for whole home backup? Our recommendation is 2 IQ Battery 10s. Okay, let's go over the key components of the Enphase Energy System. We've talked about the microinverters and the batteries, but you should be familiar with the other components as well. So here we have all the different IQ8 models that are available today. They cover a wide range of power, anywhere from power output of 245 VA, which is essentially the same thing as watts, up to 384 VA. And because it's very common to have a solar panel to microinverter power ratio of about 1.3 to 1, that means that like an IQ8H, for example, could handle solar modules over 500 watts with little to no clipping, because solar panels don't actually output their rated power hardly ever in real world conditions. That's a topic for another day, which we can talk about when sizing systems next month. And some of you may be aware that there are some modules being produced on the market that have higher amperage or higher electrical current than the Enphase microinverter models the IQ8 series can handle. It might be outside that range. We are coming out with actually 3 additional models of IQ8 series that can handle up to 14 amps of current. So just keep that in the back of your minds that we are very soon coming out with these with new models that can handle high current solar modules. Okay, just a few more interesting things about the IQ Battery 3. It's an AC coupled system. That means we can integrate other AC power sources as well, like a generator, which I'll touch on in a couple of minutes. Each one of our batteries has multiple microinverters built into it. The advantage there is that if one of the microinverters fails, it doesn't take the system out of commission. It'll still be able to operate, although the amount of power will be slightly reduced depending on how many microinverters are not working. But the point is that it'll still function, whereas other batteries that have a single inverter, if that inverter fails, the whole system's out of commission. On that note, the microinverters are also field serviceable. So in the rare chance there isn't a problem or a failed microinverter, it can be replaced on site by a technician instead of RMAing that battery and shipping a 300-pound battery back to the manufacturer. The battery chemistry that we use is lithium iron phosphate, or LFP for short. Most other companies use NMC chemistry. The advantage of LFP chemistry is that it's a much safer chemistry. They can be damaged, physically damaged, like punctured or crushed, and they're not going to ignite and catch on fire or explode. They also have very low degradation compared to NMC chemistry. That just means that a battery that's being heavily used day in and day out is going to decline in how much energy it can hold very, very slowly over time compared to NMC batteries. So for customers, especially customers that are using their batteries for savings mode or self-consumption, they're draining their battery on a daily basis, that superior longevity and low degradation is really important for them. Batteries can be installed indoors or outdoors. And because of the safer chemistry that we use, we also have a very simple passive cooling system. It's basically a heat sink and a well-ventilated cover. So no moving parts to this system. Some of our competitors on the market have multiple moving parts, liquid coolant systems that sometimes leak and have pumps and fans that could potentially fail during the long life of the battery. So our engineers looked at the different options and thought, hey, let's use a safer chemistry, and that is going to allow us to have a very simple and more reliable passive cooling system. Because of all these reasons, we can have a 10-year warranty that offers a minimum of 70% energy capacity retention after 10 years or 4,000 cycles, whichever comes first. To put that 4,000 cycles in perspective, if a customer cycled, meaning completely discharged and recharged their battery every day, it would take almost 11 years to reach 4,000 cycles. So the point I'm making is that this battery is designed for very heavy use. Okay, the IQ System Controller 2. This is the microgrid interconnect device, or smart switch, as it's often referred to in the industry, that will disconnect the system from the utility grid if there's an unexpected power outage. This model specifically, the one with the 2 at the end, is required whenever using IQ8s for backup power configurations. And the reason for that is with the IQ8, the NEC requires a separate method of rapid shutdown instead of the standard AC disconnect for the solar system. So we have to have a separate rapid shutdown switch, which is pictured here, that ties into the controller, and that will disable the IQ8s. This model can also be used with previous generations like IQ7s and M215s, etc. We do encourage you to use the IQ System Controller 1, so the first version, if you are using IQ7s, but just know that if the Controller 2 is the one that's available from your distributor, then that's perfectly fine to use it with IQ7s. Integrates with home standby generators, which I'll talk about in a minute here. It can also be installed indoors or outdoors. And it can support up to 4 IQ battery 10s. So that would be 40 kilowatt hours of storage capacity or 15 kilowatts of AC power. Okay, the next component I want to talk about is the IQ Combiner 4 or 4C. It's called the combiner because it combines the 4 solar branch circuits of an Enphase system. 4 is the limit when using a combiner. Each branch circuit has a 20 amp breaker, which means that up to 16 amps of current can flow through each breaker. That would be a total of 64 amps of current, which equates to, as I said earlier, about a 15 kilowatt AC system or about a 20 kilowatt DC system. It can also be used with earlier generations like IQ7 or IQ6. Built into this unit is the IQ Gateway, which is the brain of the system that collects information. It's the way that the homeowner and installers can control the system operation and set operating modes as well. We do recommend connecting the gateway to high-speed internet for a really good customer experience, especially if that customer is going to do live status where they can see live information from their system. A communications kit, which is that black box on the right, is also required for backup power. So again, only for backup power systems like sunlight backup or with IQ batteries. If it's a solar only system, this communications kit isn't required. A communications kit allows wireless communication between the gateway and the batteries and system controller. And lastly, a mobile cell modem is also required for any backup power configuration. Now we have these 2 combiner names, Combiner 4 and 4C. The C at the end means that model includes the cell modem. The cell modem that comes with our IQ Combiner 4C is a T-Mobile compatible cell modem. Now, if you happen to know that at this location, T-Mobile service is not very good quality, you can opt to get the IQ Combiner 4 that doesn't have a cell modem, and you can purchase separately from Enphase an AT&T compatible cell modem. So if AT&T works in that location, but T-Mobile doesn't, that's what you would want to do. A little more about the IQ load controller. So the IQ load controller is a very versatile product. Generally speaking, it allows the system to disconnect or reconnect electrical loads for system stability and for different different configurations and uses. At a very basic level, it will automatically shed power-hungry loads instantly when there's a power outage. So if you've got a large load like an air conditioner that you know is going to be too much for the battery system by itself, it's nice to disconnect those loads instantly when there's a power outage, and then the customer will have the option to go into the app and select a load that they would like to turn on manually. As I mentioned earlier, the load controller is required for sunlight backup. It allows the loads to turn on a daily basis based on a schedule when the system is disconnected from the grid. That's so that you don't have a lot of loads trying to turn on the very first thing in the day when sunlight first hits the solar panels. Otherwise, that homeowner would experience power outages and then the system trying to restart. It'd be a very herky-jerky, bad experience for the homeowner. So that the load controller in this scenario, sunlight backup, is just going to provide a little buffer zone between when the first power is produced and when the first load needs to turn on. Now, more specifically about its capabilities. So load controller can control power to 2 zones. And by zone, I mean either a single 240 volt circuit or 2 120 volt circuits. And up to 2 IQ load controllers can be installed per system. So that would be a total of 4 independent zones that could be controlled with the IQ load controller. It can also be used for solar circuit shedding. So if you are retrofitting an existing system with IQ7s, the older generation, with an IQ battery, and you need to disable some of the PV in order to maintain that optimal 1.5 to 1 ratio I mentioned, then you can use the load controller to basically disconnect 1 or 2 of the branch circuits of the PV system so that you have that proper ratio in a stable system. Just a reminder about compatibility. So if you're using the IQ8s, look at the bottom row, you must use the IQ Combiner 4 or 4C and the IQ System Controller 2. If you're installing IQ6s or IQ7s, then you can use any of the available models that are shown here. Again, we encourage you to use the IQ System Controller, the original model with IQ6s and IQ7s, but you could use the controller too. It's also important to note that in a given Enphase system or microgrid, all the solar microinverters have to be from one of these 3 families. In other words, you can't mix IQ8s with IQ7s within the solar microgrid because of a different communication protocol that's used between the microinverters in the system. So this can come up if you are retrofitting systems, a customer has IQ7s, for example, and they want to add on solar and batteries, then you would have to add on IQ7s. You would not be able to add on IQ8s to that system. Another option would be just to replace all the microinverters with IQ8s. In my opinion, it's better to take that money and put it toward the battery. I'm in a scenario where a customer is interested in sunlight backup. Don't replace IQ7s with IQ8s. Keep the IQ7s, add more IQ7s if that's what they want, and again, take that money they saved to buy a battery instead. Okay, another quick quiz here. So true or false, IQ8 solar microinverters can be added to an existing IQ7 system for sunlight backup? And the answer is false. All solar microinverters in a microgrid must be from one of the 3 families mentioned earlier. Which system components are required in addition to the IQ8 for sunlight backup? That would be the IQ System Controller 2, System Shutdown Switch, IQ Combiner 4 or 4C, IQ load controller, and essential loads panel. True or false, the highest peak power rating of the IQ8 series is the same as IQ7. So that is false. The IQ8H has a peak power of 384 VA, which is 5% higher than the most powerful IQ7. And what's the primary job of the Enphase IQ gateway? That would be monitoring and system control. I want to talk briefly about what is different about the way that Enphase works with a generator. So first, let's talk about typical generator integration of our competitors. With our competitors, the generator is connected to a transfer switch. That transfer switch means that either the generator can power the home or solar and battery can power the home, but they can't actually power the home together at the same time. Essentially, if the system like this is powered by solar and storage, if storage gets down to a critically low level and goes into standby, the system will switch over to the generator. And typically that generator is going to stay on and running until the utility grid is back up, even if that's 5 or 10 days later. Obviously a very bad outcome for somebody that wants to rely on solar power. Now what's different about the Enphase system is that the generator is tied directly into the system controller's bus bar. That means that you have AC power flowing into the same bus that the IQ battery and solar are connected to. So they all work together as a family. The generator actually is the grid signal that the solar and IQ battery will follow. Having all three power sources means that you've got all that available power from all three as well. So you could run large electrical loads during the day when all three are operating compared to when you're operating off the battery at nighttime. So the power of all three is additive. It also allows a sunlight backup system to operate and provide continuous power to the homeowners. The generator will always be on, and the solar power will ramp up during the day to meet the power demand during daytime, and the generator will supply power to the home at nighttime. Generator can also be used to recharge the batteries. So in some instances where the solar system might not be producing much power, perhaps you have a lot of wildfire smoke or storm clouds or a lot of shade in the winter, whatever it might be. You can use the generator to recharge the battery, and then when the battery gets down to a low state of charge, the generator will kick on and recharge it back up to a set level. It's a nice option for homeowners to power their home silently with the battery at nighttime instead of having the hum of that generator going all night. If a generator is connected to an older microinverter series like M215s or M250s, then it would have to be configured so that the solar microinverters would actually be off when the generator is running, because there is a risk of backfeeding power to the generator. So only to keep in mind if you're integrating a generator with very old or one of these older series of Enphase microinverters. I'm going to breeze through the learning check for sake of time here. If you like additional training, we have free courses available at Enphase University. There's a sales certification training, installation, and design. For those of you who might be new to Enphase, if you're going to be installing any backup power configuration, you do have to get certified at Enphase University in both installation and design. If you'd like more information on getting certified, please email me directly. Edgar can give contact information to you for me, and I can help you with that. All right, now I'd love to open it up to Q&A. I wasn't actually looking at questions if there were any that were typed in, so let me open up here. And Edgar, if you were following along and saw any questions, it looks like no, I didn't see any questions come in.
Yeah, so we got two questions.
Okay.
You might not be able to see them. I apologize for that. The first one, and I hope I can do some justice to this question because it's a great question. For expansion on systems that have IQ6 and 7 with the respective combiner, can we just add IQ8 and the IQ6/7 and the combiners communicate with the IQ8 on expansion? or do you recommend to upgrade all older material to the 8th along with the combiner?
So what I would recommend is adding IQ7s to that system instead of replacing the IQ7s and adding more IQ8s. That's because they can't be mixed in the same microgrid because they don't communicate using the same protocol that IQ7s. If you're dealing with a customer who is a little bit more savvy and understands electrically what's going on, you may be able to offer them basically a new system with IQ8s and a battery that will be there, that will also supplement, power anytime it's producing for solar only. But when it's disconnected from the grid, only the IQ8s and battery would provide backup power, and the IQ7 system could remain on the outside of the microgrid or on the grid side of the microgrid. And it would, in that configuration, the IQ7 system would be off when the system is disconnected from the grid. But again, that's not ideal. What I would recommend is just adding IQ7s if they want to increase their solar output and connect that to the IQ battery system rather than replacing with IQ8s.
Perfect. Thank you, Tony, for that. The next question I have is, can you control the system using the app during an utility outage or no internet or cell service? Can the app connect directly to the system?
Yes, there is a way to do that. It's not something that I'm really well versed in, but our system does allow, I can't remember what it's called right now, but it does allow the homeowner to connect directly to the gateway. I'm not sure if it's with the homeowner app or with some other mechanism. But yeah, I mean, ideally, we want to keep the internet connection. That's why we provide the cell modem as a backup. But it's possible that the cell towers could be out in that region, so cell service may not work and their home internet may not work. So we did provide a workaround way to connect directly to the system. Edgar, I can send more information on that to you after we've concluded, which you can share with the attendees.
Perfect. I appreciate that.
Sure.
All right. Well, I don't have any other questions, so that brings us to the end of this webinar. A big thank you to you, Tony, for sharing your time and your knowledge with us. Without any other questions, we will conclude the webinar. Check out AEE Solar's website for more training opportunities, as well as Enphase, and visit our YouTube page for a complete recording of this webinar if you would like to revisit it in the future. Thank you for doing business with AEE Solar, and you all have a great day. Thanks again.
All right. Thank you very much. Take care. Bye-bye.